I'm Anil Kumar. Welcome to my series on trigonometric applications. Now, I have three important examples where we will see how to apply sine law and cosine law. These examples are very important from test point of view. The very first question here is just before you, which is a person swims 300 meters north from the dock. He then turns right 120 degrees and swims 400 meters. How far from the dock is he? Four options are given to you. So I'd like you to pause the video, answer this question. Let me also share the other two questions before we get into their solutions. The second question which I am going to discuss is in the form of a triangle given here. We have a triangle ABC with height of 12 meters and this has an area of 126 meters square. So let me just drop a perpendicular from here. So that becomes the height of 12 meters. Okay. Find its perimeter if angle ABC is 80 degrees. That means this angle here is 80 degrees. And the side length A, that means this side length is 17 meters. Okay? So you need to find perimeter of this particular triangle. The third question which I am going to take involves 3D. So here the question is, find length BD, that means this length you have to find, to the nearest meter in the given diagram. AC is 50 meters, angle BAD is 60 degrees, angle BAC is 50 degrees, and angle ACB is 80 degrees. Now you can actually pause the video, answer these three questions, and then look into my suggestions. So let's begin with solving these questions one by one. So let's take the very first question now. A person swims 300 meters north from the dock. He then turns right 120 degrees and swims 400 meters. How far from the dock is he? So let's try to sketch the diagram here. Let's say this is the north, right? Okay. And okay, so a person swims 300 meters. So let's say from dock, the person swims 300 meters. So this is 300 meters for us. He then turns right 120 degrees and swims 400 meters. Now this particular statement can create two problems, which I have noticed many times. He then turns right means what? Well, right is towards this side, 120 meters. That means from this side, it is right. Correct? So he turns right and then swims 400 meters. So that is 400 meters. So this angle here is 120 degrees. So what do we have? We have 300 meters north in this particular triangle. And now he swims 400 meters. We need to find how far he is from the dock. That means this distance, right? We have to find this distance. So that is the question for you. So I hope that is absolutely clear. Let's call this as D, the dock, right? He swims to point A and then to B. So basically we need to find DB. Perfect. Now since this angle is 120 and that's a straight line, the angle DAB should be 60 degrees. Now we can solve the triangle using the cosine law. We know the two sides and the included angle, right? So since the situation is side angle side, we should use cosine law. Okay? So we can say DB square is equal to 300 square plus 400 square minus 2 times 300, 400 times cos of angle which is 60 degrees. Perfect. So that is how you could solve it. Now this could be done without calculator also, but we can use calculator now. 300 square plus 400 square minus 2 times 300 times 400 times cos of 60 degrees, which is half. And so we have taken a very special triangle here. So that gives you 130,000, right? So that is dB square. So dB is equals to square root of this number, 4 zeros. So square root of this number is square root of our answer, and that is equal to 360. The closest answer which we have here is option A, so we'll take that as our answer. Perfect. So that is how you could solve this question. So some of you might have got this thing wrong, the angle 120 if you take here, then you get wrong answer, which will be almost the double of this, which is 610. So take care in this case, look at the diagram once again and understand the situation. Okay, so let's move on and take up the next question, which is triangle ABC with height 12 meters has an area of 126 meters squared. Find the perimeter if angle ABC is 80 degrees and side length A is 17. So we can find AC from the area, correct? So area equals to half of base, which is AC, times height, which is, let me call this point as D, times BD. So we know area is 126, so 126 is equal to half of AC, which we want to figure out, times BD, which is 12, right, which is 6. So we get AC as equal to 126 divided by 6, right? So you can write this as 6 AC. So 126 divided by 6 is 21. So AC is 21. So we get this length here as 21, right? Okay. Now we know this side as 21. We need to find the third side. We could always find third side since we know this combination using sine law. Perfect. So we'll use sine law now to find the third side. So let's find the angle A first. So we have sine A over 17 equals to sine of 80 over 21. So sine A is equals to 17 over 21 times sine of 80 degrees. Let's calculate this answer. So we have 17 times sine of 80. We'll divide this by 21 equals to. So we can say that angle A is equals to sine inverse of this value, which is 0.7972, which is equal to. So let's do sine inverse of our answer. That gives you the angle as 52.86. So let's call this as 52.86. Since we need to find the third side, let's find angle C first, right? So angle C is equal to 180 minus 80 minus 52.86. So from 180, we'll take away 80, which is 100, and then we'll take away 52.86. That gives you, in decimals, 47.14. Okay. So now you know angle C. Since you know angle C, you can find the side C now, right? So let's use sine law once again to find C. So we know now sine C over AB is equal to 1 sine of 80 degrees over 21, right? So AB is equal to, from here we can say AB, just cross multiply, is equal to 21 times sine C. C is now known to us as 47.14. We are not rounding at this moment, we will round it later, divided by sine of 80 degrees. Okay, so that gives you 21 times sine of 47.14, and then we'll divide this by sine of 80 degrees. So you get 15.63. So this side is 15.63. Okay. Now we have all the three sides. We need to find the perimeter. So now we can write perimeter is equal to sum of all the sides, which is 15.6 plus 17 plus 21. So 15.6 plus 17 plus 21 equals to 53.6. The units are in meters. Okay? So the perimeter is, so our answer here in this case is 53.6 meters. Correct? So that is how, using sine law in this particular case, you could find the perimeter of the triangle. Perfect. So I hope the concept is absolutely clear. So let's get to the last question here. I think we should take a small break, watch some nature, and then we'll get back to this particular question. Meanwhile, you can always pause the video, answer the question, and then look into my suggestions. Thank you. Waterfall! I hope you enjoyed the video. Now back to the classroom. The question here is, find length BD to the nearest meter in the given diagram. AC equals to 50 meters. So A to C is given to us as 50 meters. Angle BAD is 60. That means BA to D, that means this angle, vertical, right? So assume this to be 90 degrees. That is the vertical thing. So BAD is 60 degrees. BAC is 50. So BAC is 50. So this angle here is 50 degrees. ACB is 80. ACB, that means this angle, is 80 degrees. Clearly, the diagram is not to the scale, right? So that is what it is. You need to solve this triangle. So I hope it is absolutely clear. Let's see how to solve it. Now since we know two angles, we can always find the third angle. So let's find the angle ABC first. It should be 180 degrees, take away 50 and 80. So that becomes 50 degrees, correct? 180 take away 80 is 100, and then you take away. So this is again 50 degrees. So that becomes an isosceles triangle. Okay. Now, so that means we can now find, we basically need to find AB, right? So let's find AB. Applying the sine law, since we know a combination now of opposite angle and side, so we'll apply the sine law. So we know sine of 80. So we can put AB on the top. So we can say AB over sine of 80 degrees is equal to AC, which is 50, over sine of 50 degrees. So we have used this combination. We are trying to find what is AB. Because if we know AB, then that's the right triangle. Using tan, we can find the height. Perfect? Okay. So I hope the concept is clear. So from here, AB is equal to 50 times sine of 80 degrees divided by sine of 50 degrees, which is equal to, let's calculate. So 50 times sine of 80 divided by sine of 50 degrees is equal to 64.278. Okay. Now we know AB. To find DB, which is the height in this case of a right triangle, we can use tan, right? So we can say tan of 60 degrees is equal to DB over AB. So from here we can find what dB is. So this gives you dB as equal to AB times tan of 60. AB we just found as 64.27 times tan of 60 degrees. Okay. So 64.27 times tan of 60 degrees gives us the answer, which is equal to 111.3, right? To the nearest meter, we can round it to 111, right? So our answer is BD equals to 111 meters. Okay? So that is how you could actually solve this question. So first thing is understand your diagram, label it properly, find the missing terms. An important thing was to find the side AB and then use tan in the right triangle ABD. So I hope with this you understand and appreciate how sine law can be applied to solve many given situations. Feel free to write your comments and share your views. If you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.